Hello, what's up? I'm Jun Chan, and we are back on stream for some more Purescript. So let's get right into it. Yeah, yesterday I was working a bit on a library that I've left aside and for a while, and I'll probably get back to that fairly soon. So I'm just thinking about where I'm going to put that in. Probably it's related to this number two here, knowledge management. I've reordered a bit my log here, and it's getting unwieldy, and I think that's creating some pressure for me to actually start thinking about this structure a little bit more in structured data terms, meaning, like this is a big to-do, so to speak, or a bit like what's on the workbench. And it's getting unwieldy and it's obviously textual. It's disconnected from some of the work and the tools. So part of the bigger picture project is to try and tie these things together. And so now I feel a little bit of pressure to get to work again on the knowledge management side of things. So indeed, logs are great, but what's better? So Zettelkasten is one of the things that's better. Um, the other thing that's better is basically um, sort of, how would I say this? Let's say OLogs for now. And then I'll connect this right now to this idea of OLog, and let's also say RDF in there, or maybe yeah. So we want some kind of like flexible quads that are event sourced, maybe causal using a causal tree aspect to it because we want things to be CRDT'd, which is the whole point of me toying with the chronophore library in the first place, like getting a sense of how to implement such data structure. We haven't gotten too much into the like making this performant, but I suppose this is a prototype land, so we can just probably do a little bit of work on that end. And one of the things that I've been doing a little bit on the side here and that I had before is this Purescript hypercore and also Purescript hypertry, which basically are data structures that offer maybe a tiny bit more that we want, but maybe for certain use case, a tiny bit more because it's secure in the way that it has signature and verification. It is designed for a distributed setting, so swarming and distribution of the log, and it is connected to this whole ecosystem like called Kappa, which I think I can muscle into doing basically a more generic CRDT framework. And so it might have a little bit too much overhead to do something like Chronofold, but I think actually I was doing some benchmarks yesterday, and I think removing the signing and the verification actually doesn't change the performance characteristics that much, but we're doing JavaScript still, so there might be more low level, maybe WebAssembly ways to think about the problem that might be ultimately more efficient. But maybe parameter optimization because it's still comfortably doing something like 30K operations per second or writes per second, maybe even up to 80K writes per second with a different batching strategy. So I think this is actually giving like in the good realm of like real time and responsive things, even for something like text editing, possibly. So it could be a good underlying data structure to kind of unite a little bit of the different efforts because I do want to have similar, like for the event log, I want to have a one particular choice. Then for projections, I might want to fold this into various maybe quad stores and whatever interesting. Um, like there's what is it called now? It's called TypeDB. There's also DSC Graph, the DataStack Cassandra version of. There's other quad stores and whatnot. So there's lots of things to test. There's even like Microsoft Graph Engine. That's actually a really interesting direction to go for graph databases and distributed graph algorithms. So all things I'm willing to try and interested in trying, but I like my original data to be immutable, which is what event sourcing and a fairly stable interface for event logs will give me. However, I will need some kind of event schema. And so that would probably be where I'm going. And if we go kind of RDF direction, then it's kind of quads, which is similar to what Datomic is doing. And so EADT is called, Datomic calls this a subject predicate object graph would be how a RDF quad calls it. But now I'm thinking maybe we want some kind of quad plus. Basically, we kind of want an add or whatever that is, which is um, an n-ary structure. And I think something like hypercore, or I've also looked at LevelDB and RocksDB. Those are usually good choices. There's IndexedDB because we want to be in the browser. And so there are IndexedDB based level up implementations for LevelDB. And so is there for hypercore. So that gives us a pathway to deploying our stuff on the server, but more importantly in the browser. And I think these would fit regularly, probably okay-ish, with basically data that might look like, how would you say it? The data layout might be, like 100 blocks of chronofold atoms or whatever events, and then maybe another, maybe interleaved, or maybe actually co-written with 1,000 blocks of maybe audio streaming and video streaming data. Let's call it multimedia. And then maybe 50 blocks of semantic data of some sort. So yeah, those quads, or maybe n adds or whatever, nats. Why do I want them to be more than quads? Because my intuition is that in the general sense, we will probably be able to exploit the fact that some regularity for certain things and have quads, but I think it's possible to also basically I'm interested in hypergraphs. So I think for hypergraphs, we're going to want a little bit, if we want compact representations, I think we'll want some n-ary structure, which is obviously not the best, but because we have some regularity, I think in it, even in the block of semantic data, we might have, like 40 blocks of quads and maybe 5 blocks of quintads, whatever that is, and 5 blocks of sexads, right? Sexads. So basically, I'm thinking maybe we can reduce this in terms of data layout, which might be premature optimization, but I'm thinking about how this will perform if we try to make it really fast. Maybe we can do an array of structure of array kind of thing here, maybe. And since also talking a bit more about the prototype and the structure that I wanted from it, like when we were writing this DSL, this seemed to be fitting an approach that would be a little bit more, how to say, ECS-like. And so with ECS, it's a lot about the decoupling of the data processing and the event-driven stuff from the data and the data layout, with an idea that you can go fairly fast in feeding, doing loops over a lot of nicely laid out data. And so I do want nicely laid out data, right? Is basically what I'm trying to say here. Sorry, I'm going to get my dashboard going, Stream Manager. There we go. Yes, so if we want data to be laid out neatly, then I think a structure like this would actually work. And I think that we can fit something like that where, the multimedia streaming data. I mean, I'm also thinking about things like, 200 blocks of streaming 3D, both like streaming 3D, which could be both like models and behavior. So all of these things might have slightly different shapes, but seen like filtered, then it should be fairly fast to actually go through them. And then we can plug in a more ECS kind of query aspect in the back of it. So I think it will work, and that means that our event log also is credible for non-projected things potentially, right? When it's more about like not heavy compute, but lots of data coming in, and that needs to be streaming fast. So I'm thinking maybe this will work. And yeah, just focusing back on the semantic aspects of it, that's where I feel like right now I need quite a bit of flexibility. That quads as is, which I've explored a bit before, you can get NRE, you can write RDF in an NRE style, but that's actually a lot of constraint. And even though it kind of can look pretty, it's not idiomatic RDF. So I don't know if there's a lot of advantage in doing this. Anyway, that's my kind of bit of debrief from some of the off-screen stuff, but I'm probably going to start including in streams at some later point. Okay, but today we're just going to continue a little bit with where we were at with the prototype. So the question was, how do we do side effects? So let me reopen where we were, and let's see whether, yes, so that was the error, that we were able to generate or to match the type of co-free chronofold action pure units, but when we used our co-free T transformer with an effect-based monad, then pure unit didn't type check. So, and the context of this is that we want to try and find a more generic way to compose capabilities or compose monads. So in our case, we're trying to compose interpreters, but we're trying to follow the pattern of how generally functional programmers deal with the composition of capabilities or functionalities, which is usually by building these monad transformers. And there's a lot of folklore and good practice that emerge from that, specifically the three-layer cake approach or the reader T base monad and all of that stuff. So I want to try and channel some of that wisdom. And it seems that that's the overall correct approach for building in effects into a co-monadic transformer stack here, which is one of the things that starts to become a little bit tricky right there, because then one of the questions is like, okay, well now effect is actually a monad, so don't we want a co-monad in here? One of the whole premises of how I'm approaching this is that I'd want to not have to define both the comonadic vocabulary and the corresponding monadic vocabulary. I want to derive the monadic vocabulary from the comonadic vocabulary. And that, I think, is part of the original insights from Phil Freeman. And I think it's been somewhat loosened in the work of Arthur Xavier when he picked it up. I think, and maybe exactly because of that fact that it's hard to put an effectful stack inside the Purescript comonadic interface because it's means that we need to start reasoning about co-effects, I think, and or maybe co-effects or effects as comonadic or yeah, comonadic representation for effects. I don't know. I've heard the term co-effect before. I don't know if it applies to what I'm looking at right now, but that's kind of where I'm picking it up because I think the reason why I can't make the type align is that basically effects is not a comonad. So obviously co-free T here is built. In fact, maybe it's a W here. Maybe that will make things clearer. And so chronofold um, coaction. Yeah, hold on. There's a couple of things going on here. Yeah, co-free T chronofold coaction effect. Co-free T chronofold coaction effect is chronofold space um, effect. It's the same. So that's chronofold space effect. Hold on, it's not. Yeah, there's something here about the position of the W that is a little bit weird. Yeah, I think the proper way is this way, actually, which means that then this is co of chronofold space effect. That I think will trigger another type error. Maybe not quite yet. Okay, let's see. Let's see if it does. If I remove this, so wrap free doesn't work. Let's try and go to the experiments and browser confold and Spago build here. See if we get the whole type for question mark A and too many open files. Okay. So do we have some? Okay, maybe I can just retry. Okay, yeah, can try. Yeah, I'm wondering whether the question mark A will show up. It doesn't. Because we want also wrap free enters the same error because interesting. Yes, because this right void here, yeah, it does, despite the fact that we haven't specified any value here, it's able to find out that whatever, since the wrapping monad of append opcolog is co-chronofold coaction, then it knows that it needs a that I know it's not co-chronofold coaction here. It's co-chronofold coaction of chronofold model. Yeah, I'm trying to find where it's picking up the effect type here. It must be picking up the effect type just from the chronofold space effect here. If I do unit, yeah, that's right. Oh, no, it's not right because I need identity actually. And then I need identity here. Yes, and then here, yeah, we needed co-free. So that's not unlike what I was trying to do here, right? Yeah, it's exactly that. Okay, so yeah, it makes sense, but we don't want identity. Identity has a comonad. So I'm just checking that it's type inference thing is what gives me this error, or where the error for effect in wrap3 comes from. It's just propagated down from this expectation about the output type. Okay. So several things to go from here, right? One would be, can we build a comonadic transformer stack where co-effects are a thing and feel like they do what we would expect when put into the monadic space, then they just look like effects. That would be great. And that would be assuming also that all of this like this way to address things is also sound. So that's one way forward. So let's try that a bit, because there's definitely something to learn here, even though like it feels like we're going to be a little bit alone in trying to figure these things out. They're a bit far out, but hey, sometimes it's fine. Okay, cool. I want to see whether there's such a thing as co-effect that are comonads. Co-effect, context-aware programming languages. Programming language abstraction for instance, how program access the context of environment. Wow, that's a fancy looking. Very fancy looking, right? Typesetting, da da da. Look at this thing. That's pretty. Have some practicals. Show me the example. Oh wow. That's theory. Oh wow. You can activate. That's really smart. I like all this. Show me all. Or short. Very cool. Very, very cool. Yeah, lots of theory is, even if you don't check theory though, like sequent calculus, comonatic translation. I mean, I suppose the topic is pretty comonatic, but okay, co-effects. Sample comonad. Yeah, I'm also interested in that data flow nature of comonads. Co-effects, calculus of context-dependent computation. And then, yes, of course, credit to Brett Victor for this. Okay, extensible co-effects. So that's yes. So that's Phil, and that will be obviously very relevant for us because hopefully it will connect to Purescript in some ways. So okay, there's an experiment. Oh, it's Smash. Okay, so that's what I had open actually last time we parted. So that's exactly a good way to pick up. So what is this? So first of all, it's extensible, and I think that means that it's the dual of run, I think. Because instead of being polymorphic records, it's polymorphic sums. No, even not even that. It's a different dimension. Is it? Hold on. Records. We can construct a monad of action from our comonad using Edward Knett's monad from comonad constructor co. By starting with a comonadic interpreter instead of monadic language, we can freely compose any co-effects, since unlike monads, comonads compose nicely using deconvolution. All right, so we also get composition. Also, hold on. Maybe, right, so I'm using transformer stacks, which famously in a monadic context don't compose. Because that's how I'm thinking about composing effects, because that's how I've been indoctrinated by the whole monads don't compose, therefore we use this trick in order to make them compose. But comonads do compose, and so maybe we don't need to use that language, and we can use the deconvolution to compose comonads. So, but it's not a full replacement for monad transformers in MCL since we cannot control all monad in this way. Okay, there's no way to model I/O or even exceptions in the style of either. Ooh. Okay, so those are important limitations. Okay, let me capture this, but a bit of theory here. Cofriti, coeffects match, yes. So comonads compose with the convolution. So we can bypass the whole monad transformer stack idiom. Let's put a question mark here. But we lose generality because we can't get IO or even either via co. And IO is kind of effect for us. So there's an example. Let's see what it does. Store traced state. So those are all pure. There's no real effect there apart from basically, I suppose, at the end. So it could be that what we're looking for as a pattern is we purely construct executable data structures which we pass to IO either at the end of the world. We commodically and purely construct executable data structure. So basically, because I like to think of monad like a monadic value as a recipe, right, with branching. And the way that usually then a functional programming language compiler then takes that and then transforms it. Okay, I'm going to go check out what that's. Very windy apartment has knocked out a frame in the bathroom, but I'll take care of this later. Okay, and yeah, I've only been streaming for half hour. And yeah. You know what? I'll actually take a little break. Okay, and I'm back. Did end up uh, dealing with that broken glass. Yeah, one sec. Let me close the door. Okay, let's do it. So co-effects, right. So if we can't do effects, then here, for instance, right, our interpreter ends up giving us some end goal value. And then I suppose then we could say, oh, maybe this, oh, okay. Now I'm thinking about something slightly different. Okay, the wind is still making a lot of noise. Let me try and find out a way that I can prevent that. Okay, let's try it like that. So, yeah, so we could either execute it at the end of the world or in the event loop. Because I'm thinking, I mean, we can't really wait for the execution of the whole program and then do the effects, right? We have to do things like user input and so at some point we need to in the event loop pass a new maybe new value that will shift the um, that will be interpreted. Okay, so input will be uh, drawn from the world and maybe co-interpreted as a comonadic value, and then output will be gotten from the comonadic interpreter and interpreted as an effect in the world. And that would be at each step, which all of a sudden makes me feel like this whole more machine aspect, um, the like making the time steps explicit somehow, um, and the folding, like allowing something to occur at each folding moment or pairing moment where the monadic uh, value impacts where the comonadic state space goes. Um, it sounds also a bit like what I was wondering about in here. which is that we have input monadic event and output monadic event, meaning that there is some kind of monad at the bottom of the stack. And maybe we don't have monads here. We have comonad, 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 and we compose them, but that at the bottom, we do need a monad. So maybe it means that there is a free, there is a bottom free DSL. Means that there is a bottom free monad DSL. And that maybe that's actually where, maybe that connects to the three-layer cake. Let's look at this Thomas Honeyman blog post again, because, yeah, basically, implement functions to interface with external service dependency there. Step by prefunction by layer one, later perform effects. Okay, so I think this is an inversion of control. I'm not sure I understand this, because these layers don't seem to layer. Also, it's weird because there's an inversion of control between layer one and layer two, I think. Layer one defines the interface, and then layer two is actual implementation. So, but maybe I'm not understanding this properly. But seems like in this case, the bottom free monad DSL, that could be the external service, could be layer two of the three-layer cake. The external services and dependencies. Let's see if we can, let's look back at Matt Parsons' original formulation here. Layer one is just this apt, which this is just run with run reader, I think. Layer two implement these DSLs, I think, like capabilities. So that's kind of what we're saying. Layer two is these capabilities, and they need to have like this kind of read-write aspect to them, but I think we can deal with that. And then I suppose like this pattern is that they're defining type classes, but then implementation is deferred so that you can pass implementation later on. So it's almost like there's another layer. Imperative shell. Because depending on how you run, mostly layer two, but I suppose also the parameter you pass to layer one, you can test with mocked effects and so on. So what am I saying? First, I suppose, is there a layer one in this? And there might be. It could be that actually we do want at the very outside to pass configuration in a way that's done. Okay, let me try and reinterpret that. The comonadic three-layer cake. I think we still have layer one with reader T. We have layer 2A, I think, which is free DSLs. I think we have layer like composed free DSLs, right? Which could be done using this MTL pattern, to be honest, which is this transformer pattern. It could be free DSL, free monadic DSLs composing, or MTL or transformer type classes, which to be honest might be more portable and make it so that our low-level code is actually idiomatic in some sense. But then later, there might be a layer 2b, which is the paired comonad. For 2a, but I'm not sure whether we need that or not. And then layer 3 would be a comonadic stack using sort of day plus other things. And this reader T at layer 1 also kind of makes me feel like that might be where sort of the event loop goes on. So in FRP, that would be like the Reactimate, and in Purescript run streaming, I think in Purescript run streaming, it's in the, I'm not sure where it is. Let's go run streaming. In 4 or each, I think. Yeah, it is kind of driven by, yeah, whether we're pushing or pulling. Here, I think we're pushing, so the client is doing 4 and the server is just expecting things. So kind of have this more semantic, I think. If you were pulling, then I think client would be, how would it be? Yeah, the client will wait for a request and the server would start with a request, and then would be more of a melee machine, I think. So the point being that in here, though, the looping is kind of abstracted away. Whereas in at least the low level, or at least when you look at the implementation of FRP, here you have an actual loop, you have um, an actual recursive call. Let's look at the implementation quickly, because I think that the whole there's this underlying resume data type, which does the next and done, which I think that's the melee machine, the more machine, I think. That's the thing that each time does the correct, that's the advancing a time step. And ultimately, I think does the tying of the knot, or at least in time. The run step loops, and the loop calls loop, and then it's, if there's a next step, then go. If not, you're done. So in Purescript streaming, it's kind of run step, basically. So I think a lot of this is about explicit versus implicit time, which means manipulating streams or manipulating individual values. With the Reactimate, it's kind of stream oriented. With run step, it's supposed to be more values oriented. Like each time you're not composing, I mean, you're composing stream at the outside it's not so unlike. Um, Trying to clear my mind up about some of these various differences. Um, One more implementation related question is, if you want to test this, um, what should we go for? Um, Also, where does, in the current Purescript React Explorer formulation, where does this play out currently? Like a simple counter, for instance. Like, let's look back at just a counter example. Purescript React Explorer, have this one, React Explorer. So in this example, the effect is in fact managed by React, because this hook is what gets called. And so that's where the sort of the monadic, so to speak, of the IO world in a streaming IO, dialogue IO, streaming IO world. This is a streaming from the outside. And then it's just hooked into a monadic value through the send hook. Or, sorry, a comonadic value, right? In fact, it's hooked to a monadic value, but that's built out of that comonadic type. Ah, hmm. So that's fairly close to what I was sketching in terms of having very local subscription. Um, there's a case that's sort of what we want actually, also in the UI kind of thing. I mean, we want to be able to say, do I want here to say, oh, here there's a button and that has on click? Or do I want to just be able to say, well, yeah, that does have button, but then somewhere else button on click. Um, that feels like a style thing. It would be nice to have the ability to do both. We could say, though, that proper decomposition is to say, yeah, but this cares only about layout. Now, why would you want to mix concerns about clicking? I don't even know how to realize any of that Dream API, by the way. I have no idea. Um, that's why this is an experiment. So, but what's interesting there is that this to A to B Malaki, this might be just on click gets to send a monadic, a co-monadic value, basically, right? Like, which, by the way, then begs, okay, and what about if we want to have effects there? And where do they lie? It's exactly that same problem. So there's the wiring of the kind of data flow wiring or the event flow wiring of this on click that comes from the DOM. So here I think it's just accidental. It's just because we use this library that couples JavaScriptisms and DOMisms. But we could say something like button.onClick. And okay, now I'm realizing something. Halogen came into my mind because I had been having it. Obviously, that seems to be a framework that is gaining traction. That's been there for a while. It has undergone several refinement in its design. So it would be a little bit wrong to ignore it. And I think I want to do a stream on that. So let me add it to the list of things that we want to test out. Streaming overlay, Script Explorer, Halogen. This way. It's in the list. And the reason I'm thinking about this also is because this is a little bit about sort of local and global behaviors. So which we see show up at kind of local, global state, whether like state is transient and local to a component, or whether we actually somehow maybe we want to store it, or that it's dependent on a more application level, application scope kind of global state, and that is then mapped to specific componentry. Here we have something maybe a little bit similar where we're talking about events located somewhere inside a componentry, which you could see as local, maybe in this case. You could say, well, the on-click is inside the button, and so the application as a whole doesn't need to know about that event wiring. And you could say that then maybe the response could be either local or global. It could affect the local state of the component, or it could try to maybe escape. And that started to make me think about how actually Halogen does, I think, some of these things in a similar way. I think there's ways for component to actually have slots and represent ways to wire things in and out. I think it's mostly for state. I'm not sure. Um, but yeah, there's something there about locality, globality that I think matters, because it's true that it might be easier to define the on-click event for the button where the button is in your component hierarchy. But then there's something to be said about whether the effectful stuff that happens as a result of this click, what goes on with it, right? So is the result, is this only changing local state, maybe in a transient manner? Is this changing local states? Is this changing local states length in local states from a global state, which is kind of, which means then that maybe we have some way to make the change look local from a state perspective, but that it would actually be computed as a change inside a more global state. Is this firing a local side effect of sorts, or what would that be? Maybe like a UI color change or something like that, right? Or is this firing a global side effect, like something like maybe like a push notification? How about that, right? And what does this say about what's happening inside this sand, right? Because there's something about the fact that we could do effects here if we wanted, and we could do effects here too. Um, it'd be better if we could have some value that comes out there, some result, and then we could do some effects that depend on the result. Right now, it doesn't feel like we. Actually, maybe I'm wrong here. I think we can actually get some value out of sand. Maybe not. Yeah, that's an interesting point, actually. Sand is just a to effect unit. Yeah, there's something I'm not taking into account here, which is what's happening with state in the React side of things, which is in fact pretty much exactly that wiring. It's saying that the Explorer, which sort of maybe ties the knot with the Reactimate, is doing side effects there for state hooking of the React component tree state. So this is kind of a side effectful decoration of the Common world into something that actually has effects as well. So it's extract state. Is this the same sand? I don't think so. Take the states and we extract. So state sand. Extract only takes one value. Is state the comonad in this case? Space. Yeah, I think so. I don't understand this anymore. Send takes an M, but extract shouldn't need that. We both extract and extend here. And we do run co at each step. So I think if we want to do something smart, we need to build a new Explorer. It's not clear how it's going to interface with the rest of the machinery here. Also, maybe this should be called handler. Because UI, yeah, this should be called handle, maybe. Because send is a bit wrong here. And then I need to also understand the implication of wrap free here. Wrap free takes a free monad. So that free monad, what we expect from the type checker is actually derived from the pairing types, which allows from Coco free to get to the pair. to the free pair and gets us the monad free instance. And then we can just unwrap the free. And what does this mean though? Does this mean, and I don't know why it's called wrap free as well. That looks like unwrapping to me. I mean, it looks like it's just for one step, right? Um, and that reminds me of another thing that we looked at before, whether if you have several free actions, how they need to be ran in a batch before they're moving on to the next computation tick. Let's look at wrap free again here and see what it's called here. Oh, it's just the member of monad free. And what's its monad free of various things. Yeah, I suppose it's different depending on what the, so if it's free, which in our case, yeah, in our case, I suppose it is, right? I'm actually not sure here what the F and the M are supposed to be in this. The M determines the F, right? So is this a way to link? What is our M in this case? M is cocoa free T effect blah. So that's, yeah, that's kind of free-ish. So it might be resorting to that monad free, which is indeed saying basically, oh yeah, this, the free underlying this, basically it's saying, yeah, it's saying that free F has F as the free F monad has F as its base functor. So it's linking the base functor with the resulting M. So here the base functor is, no, that's the resulting M, and you're basically trying to say this is the base functor, coconut action. And you're saying the resulting M is kind of basically free T. You could say it's free T effect chronophore correction. Could we? I don't know if we want to do that. I thought maybe there's a way to transform this into a free formulation, which would then allow us to use effects. Let's look at what other not the free co-free pairing, but the trace or the store do in that case. They also send, which is the handle, and what they handle is void of a monadic action. So they ignore the result. And use modify from the stalker monad to add to the counter, which add is gotten from oh, add is actually probably just the prelude. So the point of this is we want to be able to use our something defined in the base function or the in the base the base functor of the co-free comonad. Um, Instead, we could probably just wrap free this individual thing and then give handle the cooked value already. Do we want to try that? I already did an append prime. Let's do an append comonad, because I think it's comonadic value. Take the maybe up. Instead of returning a co-Knopfler coaction unit, it would return whatever handle expects, which is a co-free co-effect blah unit. And so, of course, there's nothing else to do but exactly what we're doing here, including the then void thingy. And then here we're just handle append comonad passing up klog. And here we have something slightly different than I was expecting. Maybe because we need to be a little bit more scoped in our, no, that's not right. Yeah, I think, oh, hold on. What's this? Yeah, so sounds like that's what we want. Affecting kernel for coaction. Did I get that type right? I might not have, because I think I've reverted things. So yeah, I think we're now co-free T kernel for coaction effect, not the other way around. So now we should have the comodatic for effect. Yes. Okay, so we're back to the same error. I don't know that I really earned anything here. Maybe localize the problem a little bit better. Yeah, the question is, do we even want effect here? And I think the answer is we can't have effect here. So if we can't have effect here, and that in fact we're not even going to use co-free chi because that's not how we're going to compose our stuff, then we're back to doing this, and this should actually compile, including with pure unit here. And then we just need to, basically backtrack and say, no, we're not going to compose things with in that way. And so quote-unquote space now doesn't take a parameter anymore. And we're back to this, and we will we'll deal with a comonadity composition with deconvolution instead. Oh, okay. So I think actually this compiles, and yeah, that's a bit of backtracking, but I think it's needed here. You know what? I'm not going to do that. I'm going to do npm start. I'm just going to check that actually we still run, and then I'm going to call it today. Because this is just a warning. And this is it's built, and if I reload, then it actually does things, and it actually shows our chronofold. So I'm going to keep it here for now. I'm just going to basically see what we do. How do we do side effects? Code-free T requirement, like we're not doing this anymore. We've checked that, but we're not going to do code-free T. Actually, we need to do smash instead, or deconvolution. Comonads compose via deconvolution. So no need to stack. Okay. So that's not how we do side effects. Do we cumulatively purely construct the data structure that we pass to UI? I think it might be a little bit of that. So in the event loop means in explore here, I think, for Purescript React Explore. So it could be that that we find a way to compose the comonadic result, that we find a way to tie in this comonadic, it's basically this stack, right? Where if we have like kind of like this, I think. That's really in Explore here. So, oopsie, something like this. And the bottom free monad, I think that's kind of right, that there is a sort of a bottom free monad DSL. And then maybe that is, this effect thing is using the bottom free monad DSL. And so a handler then becomes something that's the result of a comonadic value and some maybe suites of free monadic effects, or transformer, like that's all good too. And then maybe that's okay. Then we localize the type of effects that we have. If it's using the transformer thing, then we can abstract. We can run the effect stacks with mock interpreters. Because we don't deal with comonadic effects per se, then we keep our interpreters pure. So here gets a login, gets us a log out. So that's a question to ask actually, right? So how does this work for comonadic interpreter for chronofold log appending, which is state, right? Which is kind of state up and giving back state. And there's two things that interest me. One is if driven by outside world effect, then yeah, that's basically exactly like right now, the outside world effect is the fact that this is in a on outside world effect um, lambda, right? That's really the binding here. And then cocomonadic value and some E, right? So that's so this hookup of like this local wiring is very okay, let me write this down. Um, then we we get outside world effect values and pass them to our pure comonadic um, stack, which in our case does the log appending. I don't know if we're gaining anything through that yet. Um, in the React case, that's in a component event callback. We could maybe wire those differently, like like um, in a React context, in a React DOM context, um, make the on click blah to blah global subscription pattern. Slash event bus of sorts. Or yeah, there's a bit of a mismatch between event-driven and ECS in that sense, right? But sometimes ECS consider that an event is actually something that is just an entity, and that then triggers system. So this could be an entity plus some components as well. I suppose that in the ECS case, yeah, basically you kind of have an event queue a bit, and you have a system that gathers that and then acts on top of it. So we could say event bus or queue. Okay, and yeah, the other thing that matters is that for a stateful thing, isn't that wasteful or inefficient or space leaky. And then generally, like, are we gaining anything from Comonats here? Are we gaining anything from Comonats? Won't we be composing capability with the transformers, the bottom monad transformers anyway? Which goes a bit to the fact that right now I have a bit of a toy example, and I think I need to make it a bit more elaborate to see whether it works for what I want. So here I'll just make as a subtask here, make this example more elaborate so that we can see if there's some fitness with an actual problem slash approach, right? I think there is, but right now it's a bit counterproductive that I don't actually have an example for that. I think maybe here I had, no, that's not really even an example for that. So I think I need to convince myself that there is a use case for it. Because right now, if it's just state, maybe it doesn't matter. If the composition we're after, I mean, there's the complex interaction there of taking into account that comonads map one-to-one with components here. So maybe that's why we want to keep them for composition and layout and things like that. And then maybe the comonadic aspects will also be a good impedance match for data flow things and query things, which is this other idea that comonads are actually a natural way to express data flow and queries, which this whole idea, I think, behind the co-effect pattern and Umo Tosalu's work. And then, yeah, and query things, maybe also layout things and incremental state things. Although basically that the question is, isn't the update monad fine for that? Or like implementing something like monoid actions or group actions. And that's kind of like in the CRDT world, and there maybe lattice is there for. But yeah, that's enough for me, I think, to pick it back up next time. Thanks a lot for watching, and I'll see you on Tuesdays. Bye bye.